So rather than go through a bunch of slides sort of showing you administratively what happens with ZFS, I figured it'd be a lot more entertaining to actually show you what happens. There we go, that's how I right click.
We work our way into the world's largest font.
Everyone can read that? Close enough? All right. We'll get 2 windows up here because that way you have twice of the fun. All right, so what can we do here? Let's see. First of all, see if I have any disks available here. Nope. So we'll do it with files instead. So I'll pretend, say that I have, I don't know, a 1 gig disk. Sorry, yep. And we'll make some more disks here because we'll probably need them later. So pretend these are disks and devices, not files. Same exact principles apply because from ZFS's point of view, it's just a place to store and retrieve data. So what you can do is the way in ZFS, as we mentioned before, that you create something is there are 2 commands. There's the zpools command, which you use to do physical things with your storage pool. And there's the ZFS command, which you run to do administration of your individual file systems, set policy, etc. So of course, without any pool, you don't have any file systems. So first thing you got to do is create a pool. So you say zpools create. I don't know what to call it. How about SNIA? And give it the name of a device, disk 1. So we do that. That seemed really quick. Turns out I'm booting off ZFS2, so there are 2 of them here. So zpools data SNIA. And here you go. Using up 1 device, everything's online, no known errors, everything seems great. And if I actually do a df, I can see that I have a file system created. So with just a single command, I've now created a storage pool, by default gotten a single file system, and off I'm ready to go. So I can now create more file systems because that's what I like to do. And so I can say SNIA.
Create.
Yeah. Yes, that's right. ZFS. What am I doing? I'm creating a file system. SNIA, 1, SNIA 2. Now I can say df-h. And you can see automatically here I have 3 more file systems. Notice one thing I didn't have to do. I didn't have to say ZFS create, make dir SNIA 1, mount, whatever on /SNIA/1. It's all there, just ready to run. So again, the idea in ZFS is that you want to express your intent and let the computer figure out what it is that needs to be done. Similarly, I can create hierarchies of file systems. So you can do more than just 1 level. You can say 1, A, 1B, 1C, and there are several file systems. Why don't I make this wider so it all fits? So you can see here, not only do I have all my boot images that I've created before, but I have SNIA 1 ABC where they're mounted. Everything's great. And I could go on, copy some data here, like, I don't know, copy user bin S, whatever, into SNIA 1A. Done. Make sure that's all out on disk. If I could type, I'd really be effective. And you can see I've used up 3.5 meg copying all commands that begin with S into my new file system here. And I decided, you know what? That's really crappy. That's not where I really wanted this stuff mounted. Say like I wanted it renamed somewhere else. Instead of SNIA 1, say I wanted, I don't know, SNIA high. Oops.
Oh,
just
SNIA.
no slash. Yep. No leading slash. My fault. So it does that, and now if I do a df, I can see that I didn't have to, unmount the file systems, make their SNIA high, and remount it. I said, nope. What I want to do is I want to move all file systems under SNIA 1 to SNIA high. Poof, I'm done. No action left to take. ZFS figured out what needed to be done.
So I'm kind of feeling like I'd like to go into that var temp disk1 file and damage it.
Okay.
What might you do to be able to protect yourself from that?
You can
You
do a lot of
sure
things.
should have created a mirrored pool, but you didn't think to do that.
Yep, so just to verify that I didn't do that, zpools status, SNIA. Yep, not a mirror, crap. Well, Jeff is right, I don't trust anything. So now rather than having to go back and say, create another storage pool that's mirrored, copy all my data over, I just see zpool attach to SNIA, to which storage pool SNIA, which device I want var temp disk1, not disk bang, disk1, var temp disk2. So I do that, I say zpools status SNIA, oops, now I got a mirror. And as you would expect, as soon as we attach the other side of the mirror, we got to copy all the data over. We didn't copy the entire gig because we didn't use 1 gig, we only used 3.5 meg. You can see the resilver completed after 0 hours and 0 minutes with 0 errors, well, just a few seconds ago according to my laptop, which has the wrong time. So that's all great, everything's wonderful, and now Jeff wants to go and damage our world, wouldn't you know it? So in order to make sure there's no caching going on, we use the zpools export command. And what export does is say, unmount everything, forget about it for a while, maybe we're going to move it to a different computer or something like that. So now if I do a df, none of that stuff is around. So now we can go to var temp, and we'll do a dd from dev0 out file is var temp disk 1, count equals 10, block size equals 128K, I don't know, OSEEK equals
Oh, I don't know.
28?
Meg, sure, pick a number.
Okay, 35.
All right.
So what this does,
And conv equals no trunk.
oh yes, I always forget that one, thank you. So what this tells DD to do is don't truncate the file, because obviously that would damage a lot more than just the few blocks that I'm doing here, and just randomly copy over 35 128K blocks into the device, just 0 out 10 of them. So we do this, copy 10 blocks as you would expect, and now zpools import, and if they were regular disks, you wouldn't need to specify this command, but since they're not, they're actually files, I got to tell it what directory to look into. And say, oh, here's a pool you can import. I say, that's great. Why don't we import it then? So I do a zpools import, and now I do a zpools status. Everything seems great, but let's go into, say, SNIA -a, do a sum on all these files. Cool. zpools status SNIA. Whoa, what's this? 34 checksum errors. And you can see in the status that it says, 1 or more devices has experienced an unrecoverable error, an attempt was made to correct the error, and the phrase that pays, applications are unaffected, meaning that all the errors that we found were actually of the correctable variety, and we were able to repair them without showing any errors to the application level. Action, determine if the device needs to be replaced and clear the errors using zpools clear, or replace the device with zpools replace. Little URL you can go to get a little more information about that. How helpful. So yeah, let's replace that disk, darn thing. So I say zpools replace, just like it told me to, SNIA var temp disk1 with var temp disk3. So I do the replace, zpools status. Oh boy, look at that. Replacing.
That's intriguing.
Indeed it is. Replacing. Maybe it doesn't work right with files. So, too many errors. So I shouldn't have to do this. Sorry.
Yeah.
Yeah, this is supposed to happen automatically. Oh, really?
Huh. Which build are you running?
Apparently, it finally did get around to it.
Oh,
in
that's
the time
right.
it took me to write.
Because the detach is asynchronous.
Ah,
It just hadn't
okay.
gotten to it yet.
Yeah, because there's so much else going on. So as you can see, I was just not patient enough. It actually wound up doing it all on itself anyway. Because by the time I got around to typing, it's like, oh, it's already gone. What are you talking about? So the resilver completed. There are no more errors. You can see that now it's a mirror between disk 2 and disk 3, and the world has driven on.
So just for those curious, what I was just mumbling, when you finish resilvering a device, we then asynchronously detach it. That happens as part of the async tasks that we do at the completion of a transaction group. It used to be that we would push out a transaction group at least every 5 seconds. Due to some changes that went in since the last time we did this demo, that time limit is now 30 seconds, which kind of screwed up our stage timing.
Yeah, that's right. So
There
now
you
we
go.
know what the problem is. We'll make sure not to do that again. And so here we are. So what else can we do? Well, I really didn't like that mirror in the first place. So now I can say zpools, zpools detach, because mirrors just make me feel too reliable for temp disk 102. Zpools status, SNIA. What did I mistype?
Stouts.
Yes, status. And now you can see we're back to an unmirrored configuration here. So now, what about those ditto blocks I've been yakking about? Zpools export SNIA. Oops. I was actually CD'd there, so it didn't want to export it because it had to unmount the file system. So here I am, once again, in the state where nothing's cached, nothing's remembered, just these devices sitting out here in var temp. Now what I can do is I can say bring up that dd command again.
You did need to just change it to disk 2.
Yep. And now, instead of dirtying disk 1, it's actually disk 3 I'm going to need to dirty.
Oh, 3? All right, 3.
So now I will just dd over some blocks of this device that is only a single copy. Now I'll do my import. And now zpools status. Seems fine. cd SNIA high A, sum everything. Oh boy, some of this stuff worked. Some of it I got an IO error. Wasn't that weird? zpools status SNIA. zpools status SNIA. And now, what the heck happened here? 66 checksum errors. ARG. One or more devices has experienced an error resulting in data corruption. Wah, wah. Applications may be affected. So what should I do about this? Restore the file in question if possible. Otherwise, restore the entire pool from backup. Well, 33 data errors. Use -v for a list. That sounds interesting. What does this say for me? Status -v. And what this shows me is a list of files that happen to get corrupted. And again, the great thing about it is I can cd around here. I can make dir Jeff, copy user bin jstar to Jeff. I can still use the file system. And as you saw before with the output of sum, any file systems that aren't corrupted, I can actually run sum on those and get the right answer. And any files that were, sun2, that's awesome, that were actually corrupted, I got an IO error, and I can, I now have a list of files that I can restore from backup. So there you go. We happen to experience a corruption. If I say zpools scrub, because now I really don't trust anything, SNIA, zpools status, SNIA. Yep, 136 errors. Boy, this is getting worse and worse, but same 33 data errors. Now I feel that I have a much more complete list of what needs replacing. So I'll just say cp user bin star to SNIA high A. I could just say, for each file in here that copy that one, but this is easier. Sync all those out to disk, and now say zpools clear SNIA to forget about all those errors, and say zpools once again scrub zpools status SNIA. Excellent. Everything's back. I restored all my files. Everything is great. So once again, just a sort of corruption that would normally make any other file system, weep on its knees is conveniently survived here. Any data that wasn't corrupted, I could still get at. Any data that was corrupted, conveniently listed in zpools status-v, and life goes on. Anything else we should? Oh, I know one.
Okay.
So that's all great. So now we say cd to SNIA hi b. So we do a df here. We've used 18K, not much at all. No files here. Copy, I don't know, kernel gen Unix to here. Sync, do it ls-lh and gen Unix. You can say it's a 2.8 meg file. Oops, do a du on the same thing. You can see 2.9 meg because in ZFS we actually account for all the metadata associated with the file, because if you read the man page on du, what it's supposed to represent, how much space would be returned to the file system if you remove that file. So because all of our metadata in ZFS is dynamic and we allocate it as it's needed, how much space would be returned to the file system if you delete this file? Well, all the space of the file plus all of its metadata. That's how much. And so there's your answer.
So do you return 0 if you have a snapshot present?
That's a very good question. Why don't we find out? So ZFS snapshot SNIA hi b. Oops, at, I don't know, now. So cd SNIA hi b, my .zfs directory, cd into snapshot, cd now, and do ls-lh and gen Unix. Oops. G Unix. So there in the snapshot, it's still consuming that much. I try to remove it. God, can't type, I swear. Yes. Oh, sorry, can't. cd SNIA. What was it? Hi B. Yeah, that way I don't have to type. 2.9 meg. So in the case of a snapshot, it's a much more complicated question to ask. So however, if I were to say,
ZFS list, we'll give it to you.
yeah, so ZFS list, SNIA hi. This actually will give you the kind of answers you're looking for. So you can see right now that for B, it's using 2.9 meg, and it's referencing 2.9 meg. The snapshot is using no space, really, because compared to the live file system, there are no blocks that are unique to the snapshot. And it's referring to the sum of 2.9 space. Available doesn't make any sense because it's a read-only snapshot. So now let's say that we were to say recopy the file. Kernel gen Unix to dot. Sync that out, ZFS list. Oops. Well, this will do just fine.
Do the previous one.
Yeah, so now you can see that the file system as a whole, including all of its snapshots, is using up this much space. Of that, 2.89 meg is unique to the snapshot because I just completely overwrote that file. So with this information, you can actually figure out where's your space going. Is it in the live version? Is it in the collection of it plus all its snapshots? Is it just data that I would get back if I deleted the snapshot, et cetera? So now, where am I? I'm right here. So now let's say I want to say ZFS set compression equals, I don't know, how about LZJB on SNIA hi B. Now I can copy my favorite file to gen Unix.
Actually, your favorite file doesn't exist.
Yeah, I know. Because I can't type. Sync that all out, do a ls-lh on everything. And now what you can see is that the original file, because I copied it when compression wasn't happening, takes up the same amount of space. Turn on compression, takes up a lot less space. But we can change it even further. We can say, you know what, that LZJB algorithm, I've heard about that. I've heard that gzip does sometimes better. So I set that. And now I'd copy it to say gen Unix 3. Make sure that's all out on disk. And now I can say, wow, look, gzip-9 actually does do better, 1.2 meg as opposed to 1.8 meg.
Although LZJB does use a lot less CPU.
Indeed it does. So there's compression, snapshots. I guess we could do a clone, right?
We could do anything you want.
We could. Any requests? No? Anything you don't believe?
Actually, how are we?
Any deduplication technology or any thoughts on where you're going with that?
Yes, we are adding it to ZFS as a fundamental primitive in the file system. So what we're doing there is we're having essentially requiring for deduplication that instead of using the default CPU-friendly Fletcher checksums, that you use something cryptographically strong. Otherwise, the probability of hash collision is just too great and makes the whole deduplication far more expensive if you have to worry about collisions all the time. So we're adding it such that we'll have a auxiliary data structure inside ZFS that for blocks that are deduplicated, we have reference counts for them so that then when you free them multiple times, you can know when the block is free and in use. The birth time tricks don't quite help us in that regard because references can come from anywhere, from inside snapshots, from outside snapshots, from multiple places in the same transaction group. So we are adding fundamental deduplication as, once again, a primitive. And the great thing about that, as Jeff pointed out earlier, is that in the DMU and SPA, where that functionality will be added, anything that sits on top of it, whether it's a POSIX-compliant file system exporting stuff over the network, whether it's a database, whether it's PNFS or Lusser, whether it's a block device, all of those will get that inherent deduplication functionality.
Right, and one of the places where, for example, that tends to be most interesting is when you think about people who are interested in having this technology, but are not able to run ZFS as their native file system because they currently are running a bunch of Windows XP servers or clients, whatever it might be. The nice thing is you can then export an iSCSI target to them that's backed by ZFS and then have all the dedupe happen at the level of iSCSI. So what's actually happening then is for multiple clients, you've got NTFS being deduped by ZFS on the server side.
Yep. So by exporting stuff in block devices like that, you can really add deduplication to any file system anywhere. You had a question?
You turn on compression after having stored some files, right?
Yep.
So the subsequent files will be compressed and the earlier files will stay uncompressed.
Yep.
And in that state, if you back up and restore, will everything get uncompressed?
Everything will be then compressed, yes. Because what happens is, because all this is designed to be concurrent, what we do is any blocks that are that begin life after you turn on compression are then compressed as they're written to disk. So from our point of view, it doesn't matter if it's a restore or fundamentally new data that you're adding to the file system. Everything after you flip that switch, you've expressed the desire to have it compressed, so we compress it. In the future, one of the things that makes, you may ask, well, that's great, but I actually wanted all the data I had on there before to be compressed too. And the thing that makes that difficult is snapshots, which are fundamentally a read-only mechanism and can have multiple references to a single block. Being able to take that block and then make it compressed in a transactionally safe way turns out to be a little tricky. We have a solution that's undergoing code review right now, so that functionality will also be introduced in the near future.
Yeah, but the key, what you get with that is, it sounds very unsexy. If you follow the ZFS discuss list, it's called BP rewrite, meaning the ability to rewrite a block pointer. And it doesn't sound like much, but once you have the ability to atomically change a block and all the things that reference it, such that's transactionally consistent, then what that gives you the ability to do is create a whole bunch of services that are quite interesting. One is the ability to say, turn on compression, and then go back and as a background task, retrospectively compress all that existing data. Or once dedupe shows up as a feature, then you say, gee, I wish this pool had been deduped in the first place. It wasn't. That's okay. You can now go do the rewrite, the BP rewrite, and it'll go back and dedupe things as it goes. Same thing applies to encryption. If you decide that you want to do online defragmentation, really that's just, again, a case of saying, I want to take the data that I have, lay it out a different way. All that really means is moving it. So once you have the ability to move block pointers inside a snapshot safely, lots and lots of cool things flow from that.
You had a question?
One question is about the
No, so the Uberblock in particular. So remember, we were talking about ditto blocks and how there are multiple physical copies of this. In the case of Uberblocks, we actually have an array of the last 128 Uberblocks that were written to disk. And we store those on multiple physical devices in the storage pool, assuming they have multiple. And we store 2 copies at the front of the disk and 2 copies at the tail of the disk, so we can transactionally update these, in your standard, 2 or 3 phase update, whatever it winds up being.
Right.
And this way we have at least 4 copies in the case of a single device, or many, many copies if you have multiple devices of the most recent Uberblock, plus the 128 Uberblocks before that, such that if all copies of the current one don't checksum, then you can find the next oldest one that does and at least get access to some of your data.
Right, so what we do is when you open a storage pool for the first time, we read in every possible Uberblock. And then among all the Uberblocks we find that have a valid checksum, we take the one with the highest birth time and say that's the last transaction group that successfully made it to disk. And then in case that was only like one Uberblock, because there was only, let's say you had lost power right after writing the very first copy and none of the other copies had been written, that would be bad. So what we do is, having decided that that is the first Uberblock, the next thing that we do as part of opening the pool is write multiple copies of that Uberblock, just in case there was only fewer than the normal number because of power loss.
Does that make sense?
No? All right, we'll draw a picture after this. You just come up and we'll draw. It's easy on a piece of paper.
Okay.
My second question is, you brought up the concept of universal storage, right?
Right.
One of the use cases is that you can put iSCSI on top of the ZFS to be able to make a block device out of it. So what about the performance impact like that? You're essentially converting block to underneath the ZFS is the real block device, and the block to ZFS and the ZFS again to block. Isn't that sounds like an overhead in the ZFS layer? I mean to say to make a block device.
Right, so there are a couple things. First of all, you got to the only thing that's really an overhead in that picture is the CPU. Because really, a write comes in, eventually you're going to send a write to disk. So the workload on your I/O subsystem is going to be identical in either case, whether it's a straight pass-through or whether you go through all the layers of ZFS. So what that means is the only thing really that could possibly be a performance disadvantage is the CPU overhead of ZFS, which compared to ingest rates, whether you have 10 gig networking or several 1 gigs trunked together, the speed of today's CPUs vastly dwarf whatever can come into the box anyway. So CPU overhead is usually not a problem for anybody. Furthermore, you get all the advantages of ZFS because sure, taking an iSCSI block and writing it to disk is fine, but if I have compression, encryption, deduplication, oftentimes that'll actually make things go faster because there's actually less work to do on the I/O side then. If I take, 100 meg of incoming data, compress it down to 30 meg, well, I just saved myself a lot of work. Or if I deduplicate it down to 10 more references on blocks that I already have, didn't have to do any I/O really. And again, saved myself a lot of work. So in the worst case, you have CPU overhead, but in most cases, you actually wind up going faster because all the layers in ZFS can actually save you a lot of work that you would otherwise have to do. Does that make sense?
So what if the CPU itself, for example, somebody doing iSCSI software offload, not software target, right, for example.
Yep.
The CPU will be used to provide
Right, but think about how fast modern CPUs are. At least the benchmarking we've done on Solaris, a quad-core single-socket CPU can easily keep up with a 10 gig networking interface. So there's usually a lot more CPU than whatever networking interfaces you have coming in. So if it were the case that your CPUs were slow enough and your network fast enough that it was all they could do to keep up with network traffic, then yes, you would have a degradation in performance. But no modern system today that I'm aware of has trouble keeping up with 1 or 2 incoming network interfaces like that. So it's really just a question of, your incoming ingest rates compared to the power of your CPUs, that winds up being usually not a problem. You can construct situations where it is a problem, but most people don't run on the hairy edge like that.
Right. It would really only be an issue fundamentally if you had a basically single-threaded operating system where you said, okay, I can only have one core worth of work going on. But in any multi-threaded operating system where you can do all this work in parallel, which we do with remember I mentioned before, the I/O pipeline? One of the things that it does is fan out across many threads all the work of compression and checksumming and that sort of thing. And if you've looked at the roadmaps from Intel and AMD, and I won't get specific because I always forget which of that is under NDA and which is public, but more cores are coming. There's going to be lots and lots of concurrency in systems, and lack of CPU is not a problem.
In the foreseeable future.
If anything, it's figuring out what to do with it, given that it's multiple cores rather than one fast core.
So anywhere do you have the CPU utilization and
Yeah, of course. Well, there is no one single answer because it depends on what checksum algorithm you choose, because SHA-256, for example, is a lot more expensive to compute than, say, Fletcher 2 is. It depends on if you have compression enabled and which compression algorithm you're using. It depends on if you're doing encryption or not. It depends on what networking card you have, whether it has, say, TCP offload or not, whether that's done in the CPU for everything or whether you have offload on the card. Depends on how many disks you have. In other words, is there enough I/O bandwidth to consume a considerable fraction of your CPU memory bandwidth? So there really is no one answer saying, with workload X, how much of the CPU do I use? It's really something you need to try it out if you have a benchmark that you want to run. And what invariably I'm sure you'll find is that the CPU overhead in ZFS compared to not using ZFS, there's going to be some delta, but it's not going to be that huge.
So let me give a high-level summary of what you're saying. If I'm running an enterprise and I have currently a storage array and I'm running my applications over a storage array, and I think I have this great little application set up, what you're saying is I could throw away that storage array, just buy a bunch of cheap disks, take Solaris, put ZFS on top of it, and I'm much better off than what I was before.
Yep.
In a lot of regards, yes.
Is that right?
Yeah.
Okay.
In a lot of regards, but not all regards. For example, if you have, say, like a VM type environment where you're going to be migrating this VM across a whole bunch of hosts, well, then direct attached storage doesn't really make sense for you. You need fundamentally some storage that's visible from everything. So whether it's an iSCSI SAN, whether it's FCOE, whether it's fiber channel, fundamentally what you want is you want storage that's visible from everywhere you may migrate that VM to.
So essentially what has happened is the storage vendors have come up with this nice little features to take care of deficiencies on the host side or whatever. And you're saying, really the storage vendors are not doing a good enough job. We can move that all into this host and we can do everything ourselves.